So this is coming back to do the second problem. I erased the first problem so I had room to write. This is potassium sulfide plus hydrochloric acid. Still a double replacement, so I have K plus and Cl minus, so it just becomes KCl, which is aqueous, plus the H then goes with the S, so I have H with a single plus, S as a 2 minus, so it becomes H2S. And this is one you have to recognize when you see that as a product. It doesn't go any further, but it is a gas. So my overall reaction is potassium sulfide, aqueous, plus hydrochloric acid, aqueous, goes to form KCl, aqueous, plus hydrogen sulfide as a gas. So now I need to balance it. I have 2 potassiums here and 1 here, so I'm going to put 2 in front of that. I have 1 sulfur, 1 sulfur. I have 1 hydrogen and 2 hydrogens, so I'm going to put a 2 in front of this. And I'm going to check and see, and I have 2 chlorides and now 2 chlorides. So it's balanced. Now to write out the net ionic reaction, all this splits up, so 1 times 2 is 2 K pluses, plus 1 times the 1 is just S2 minus. 2 times 1 is 2 H pluses. 2 times 1 is 2 Cl minuses. Goes to form 2 times 1 is 2 potassiums. Plus 2 times 1 is 2 chlorides. Plus then my H2S. So my potassiums cancel out. Sulfurs do not. Hydrogens do not. So that leaves me chlorides. So I have S2 minus plus 2 H pluses goes to form H2S. Again, it's not the traditional OH minus and H plus goes to water. Okay. And just like last time we have, there's one more example of this. Okay, now it's calcium sulfite as a solid plus hydroiodic acid aqueous. Still double replacement, so I have calcium, which is a 2 plus, I, which is a minus, so it becomes CaI2, and that's aqueous. Plus, I have H plus, I have SO3, 2 minus, so it becomes H2SO3. Okay, this is one of the compounds that should go ding, 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 because it's not stable. So I need to realize that that goes on to further form water plus sulfur dioxide. So whenever you see sulfurous acid, H2SO3, or carbonic acid, H2CO3, as a product, realize it needs to undergo further reactions. So to write my overall reaction, I have calcium sulfite plus hydroiodic acid goes to form calcium iodide. Oops, this one's aqueous. Plus water, which is a liquid, plus this, SO2, almost said CO2, as a gas. To write the complete ionic, this doesn't break up because it's a solid, so this stays CaSO3. Plus, this does, I forgot to balance it. Alright, I've got 1 calcium, 1 calcium, 1 sulfur, 1 sulfur, 3 oxygens, and 3 oxygens, 1 plus 1 here for the water and 2 here for the SO2. I've got 1 hydrogen and 2 hydrogens, so I'm going to put 2 in front of that. And now 2 times 1 is 2 iodides, and 1 times 2 is 2 iodides. So all I had to do is put the 2 there. So now I have 2 H pluses plus 2 I minuses. Goes to form, now this is aqueous, so this forms Ca2 plus 2 I minuses plus water plus SO2. The only thing that's going to cancel is my iodides. Nothing else. Calcium sulfite's not over here. Hydrogen's not over here. So I end up with calcium sulfite plus 2 H pluses goes to form water. Whoops, I forgot one. Calcium 2 plus water plus SO2. So that's the net ionic reaction for that one. Okay, now we have one more example with nomenclature, and that is this one. Okay, so I have barium carbonate and hydrobromic acid, okay, as an aqueous solution. This is a solid. It tells me that here. Okay, so barium is Ba 2 plus, carbonate is CO3 2 minus, so that just becomes BaCO3 because the 2's cancel, and it says it's a solid, plus hydrobromic. So the hydro means that it's just 2 elements with hydrogen and whatever this is indicating. So this is going to be H plus and Br minus, so it's HBr, and it tells me that's a solution, so that's aqueous. And now it looks like what we just did. We just have this additional step. Again, if I give you this type of problem, the nomenclature is separate to the rest of the problem, as long as you may lose points if you don't have the right compound, but as long as you go forth from there and continue that using that compound, you won't lose the rest of the points. Okay, so barium goes with bromide, so I'm going to keep writing up here since I have the space. Ba 2 plus and Br minus becomes Ba Br 2, and that one's aqueous, plus H and CO3, so H plus CO3 is a 2 minus, so that's H2CO3, ding, 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 not stable, so that goes to form water as a liquid, plus CO2 as a gas. Okay, now I need to balance it. I've got one barium, one carbon, and one carbon, 3 oxygens, and I have 1 plus the 2 is 3 oxygens, 1 hydrogen, 2 hydrogens, so I need to have a 2 here, and now 2 bromides and 2 bromides, so it's balanced. Okay, again, this is a solid, so it doesn't break apart, so it becomes BaCO3. You really don't need to write that for the net ionic, but plus 2, or for the complete ionic, plus 2 H pluses, plus 2 bromides, goes to form Ba 2 plus 2 bromides, plus water, plus CO2. The only thing that's going to cancel here, just like the last one, is the anion bromide. So I have barium carbonate plus 2 H pluses, goes to form barium 2 plus water plus CO2. And that is my final equation, my net ionic. And that is the end of this section of the textbook.